Now we shall be looking into the concepts of mutual inductance of two long solenoids. So, the mutual inductance of two long solenoids such that both the solenoids will have their same cross-sectional area as well as their length, right? So, for example, we check like a solenoid has been taken. Over there we want to find out the mutual inductance. First of all, we know that there are two. One is primary coil and then other is secondary coil. In the primary coil, actually the current flows, and due to the flow of the current in the primary coil, magnetic flux has been produced, and due to the time varying current in the primary coil, the magnetic flux that is produced, it changes with respect to time, and thus it is also associated with another coil, the secondary coil, which is kept in the neighborhood of the primary coil. So the secondary coil now observes the same magnetic flux change with respect to time. So thus a production of an induced EMF will occur in the secondary coil, right? So the magnetic flux which is induced or which is produced by the primary coil due to the change of current or time varying current will be equal to, this is done by the primary coil, right? And we know that for a solenoid, the magnetic field, the magnitude of the magnetic field that is being produced is mu naught Ni divided by L, right? So since it is a primary, we should take it as mu naught multiplied by the number of turns in the primary coil multiplied by the current flowing in the primary coil divided by the length of the primary coil. But it is said earlier that the length of both the coil will be the same. So over here, L equals to length of primary coil or length of secondary coil, right? NP here stands for number of turns in primary coil, and NS here stands for number of turns in secondary coil. IP here stands for the current flowing in primary coil, right? And we could also take A as the cross-sectional area of primary coil or the secondary coil, where the term coil represent the solenoid in this case. Right? So this is B. So first of all, let us write that this is not phi and this is B as we have written over there. Right? And we know that phi is equals to N B A cos theta. In this particular case, theta is 0, which implies cos of theta equals to cos of 0 is equals to 1. Right? Now, this phi or this magnetic flux, it is for which coil? The secondary coil, right? Because only for this phi, when it gets associated with the secondary coil, an EMF of opposite direction will come into play, right? So the number of turns that will be associated now will be Ns, or the number of turns in the secondary coil. B obviously will be for the primary coil, and A could be the area of the cross-sectional area of the primary and the secondary coil, right? And cos theta here is equals to 1. So we can write this now as, we are putting now the value of B over here, mu naught NP NS multiplied by IP divided by L, and this cos theta will be equals to 1. So this is the mu naught, this is the NP, this is the NS, and this is the divided by L, and this is the IP. Entire term contains about the NS, B, and now the area. Right? Now, if we are going to take that this phi, we could write as MIP, or the mutual inductance multiplied by the current flowing in the primary coil. IP, the current flowing in the primary coil, right? So, the IP could get cancelled like this, okay? And we could get the equation of M will be equals to mu naught, number of coils in the primary multiplied by the number of coils in the secondary divided by the length multiplied by the area. So this is the formula which we get for the mutual inductance. Now, if we take small np as number of turns in primary coil per unit length, and likewise we take ns, small ns, as number of turns in secondary coil or the solenoid per unit length. So what is the value of NP actually is? The value of NP now will actually be equals to capital NP, the total number of turns in the primary coil, divided by the length L. because this is the number of turns in the primary coil per unit length. And likewise, we could write small ns equals to capital NS divided by the small l. Right? So in this equation, we could also write now as M is equals to mu naught multiplied by NP divided by L multiplied by NS divided by L. We are taking an extra L in the denominator, so obviously we have to multiply it by the L over here, and this will be now multiplied by this cross-sectional area, right? So we could write this mutual inductance as mu naught multiplied by the NP divided by L. We could write as small np, and this small np, we know it means the number of turns in the primary coil per unit length, and multiplied by the small ns, or the number of turns in the secondary coil per unit length, multiplied by the length of this like L, the length of the primary coil or the length of the secondary coil, multiplied by the area. So this is also a formula which we get in terms of number of coils per unit length of the solenoids, right? So this is all about the mutual inductance or the mutual induction. So in the next subsequent lectures, we shall be saying that how we could use these concepts, these fundamentals, in order to devise the circuits of an AC or an alternating current. So look out for more videos and enjoy the physics classes. Thank you.